could you wait for some other people to join? Yeah, and we are live. Ruby Book Club, Junior Dev. Today we are covering chapters 11 and 12. It's me and Nelson this time around. Yeah, in case you're watching, in case you get to watch this on YouTube, kindly consider joining. Yeah, we need new people to do this thing with us. So, like I've said, we're covering chapters 11 and 12. Yeah, chapter 11 covers a topic that up until this point we hadn't tackled before: operators. And I think in the simplest form of the word, arithmetic operators, addition, subtraction, um, division, multiplication, and of course some other more obscure operators apart from those four common ones. So the chapter starts off with showing you how the addition operator works. You have something on the left of the addition operator, and something on the right of the operator. And then on the extreme left, you have a variable that you're assigning a value for this operation to. So you in the book you have a variable named sum, and sum is the addition of the first and the second. Yeah. I don't know if Nelson, you're at that point in the book.
What page are you on? It helps to say the page number.
The page is currently 130, but I have a PDF version, so I think all I can say is that it's according to the book outline, it's page 157. I don't know, you could try checking on page 157. But it's at the very start of the chapter, like the second page.
Yeah. So that's page 130 in the book. In the PDF it says 158. The page numbers
Yeah, 130.
are at the top and bottom. You can see the page numbers. So 130, chapter 11, defining operators respectfully.
Yeah. So you're performing this addition operation. You have the first and the second, and then you're getting the value and you're assigning it to a variable named sum. And this caught me by surprise. But even the addition operation involves a method call, just like so many other things in Ruby. So to put this in a more, I think, verbose way, you have sum is equal to first, and then you're calling the plus method on the first while passing in second as the argument. And I think this is something that is to be noted when it comes to operators in Ruby, that just the mere fact of working with operators similar to the way you do other things in Ruby, this still involves calling methods on a given object and passing in another object as the argument. In this case, we are calling, like I've said before, the plus operator. No, the plus method on the first object, and we are passing in second as the argument. Yeah.
Yeah, I mean, I think we can
And
be a little
then
bit more explicit about why it's surprising. And the reason it's surprising is because in other languages, the plus operator would be a keyword in the language, and so it's you would expect it to be a special, unique thing defined in the language um, that you cannot change or alter. In Ruby, because it's a method call and because you can arbitrarily override any methods, the plus operator, when you override it, you can tell it to do whatever you want, you know. And
Oh,
sometimes
yeah, yeah.
that's a good thing, and sometimes that's a bad and confusing thing. But it gives you the power to change the language on the fly.
Yeah. So that really caught me by surprise. I thought it was just, I don't know, just simple arithmetic, adding things. But apparently it involves calling a method on a given object and passing in another's argument. So proceeding from that, we see still page 130. We see another example that shows us what the equivalent of our addition operation when combined with a multiplication operation and a subtraction operation, how that statement would translate when written in a more explicit way, where you show the exact method that is being called and which object is being passed in as the argument to that method. And I see that result is equal to first plus second times the value of the third minus the fourth. Keep in mind that third minus fourth, this is in brackets. So they're saying this will smoothly translate into result is equal to first. You call the plus operator, no, the plus method, sorry, on the first object, and you're passing in the rest of the statement on the right hand side as the argument. But the argument of the plus method can also be broken down further to show you the argument of the multiplication method call on the second object, whereby you have the value of third minus fourth being the argument of the multiplication method call on the second object. And I think when Ruby is trying to make sense of this, these two statements are the same, the one above and the one below, they'll result into the same thing. Yeah. And then Nelson has talked about overriding a given operator and making it do whatever thing you want to do. I think that is the next code section. You have a method that is using the plus operator and passing in other as the argument as part of the document class, and you're going to literally combine two documents to form a bigger document. And by this we could get the final content of the bigger document by calling total documents dot content, which is basically calling the content method on the total document object. And then we see that by this we are going to have an output of these are the voyages of the starship. And I think this is showing how you could override the the inbuilt functionality of the plus operator, and in this case you use it to get a bigger document from two mini documents by adding them together. Yeah. And then we see syntax that is a bit familiar in this section of sampling of operators, page 131. You've created an array called names, and you're adding names to this array using the bitwise left shift operator. I think most of us have encountered this. And what this section is saying is that plus is not the only operator you can overload. Ruby allows you to define more than 20 operators for your class. Of course, when we go back to arithmetic, some of the more common ones are the subtraction, division, multiplication, and maybe the modulo operator. And then you can also have the bit-oriented operator and the exclusive OR operator. And then in addition to the bitwise left shift operator. So this section of the chapter introduces a concept of an operator being either binary or unary. And basically, a binary operator, you could think of it as an operator that performs the act of dealing with two objects and bringing those two objects together. So for a binary operation for something to be classified as a binary operation, you need a pair of objects. And then as a very simple example of a binary operation we've seen before is the addition operation, whereby we had sum is equal to first plus second. We needed a pair of objects, the first object and the second object, and we assign the value of that operation to the variable sum. So that is an example of a very simple example of a binary operation. On the other hand, a unary operator or a unary operation involves a single object. And the author includes an example, a very simple example of a unary operator, which is related to the bang, that exclamation symbol that we saw previously. I think in the very, very first chapters. So page 132, we define a method, and the method is related to that exclamation mark. And what this is going to do is that when we create a new object of the document class, a new instance of the document class, and we pass in favorite as the title of the document, the name of the author as Russ, and chocolate is the best as the content, we can call this method and pass in favorite as the argument for us to have an output of it is not true, chocolate is the best. And why do we get this output? In the method definition, which is defined in the document class, we see that we are supposed to get an output of it is not true, and then we fill in the content that was provided when creating the instance of that object. In this case, the content is chocolate is the best. So our final output of calling this method and passing in favorite as the argument will be getting the statement, it is not true, chocolate is the best. I don't know if you have something to add on, Nelson,
Yeah,
so
I mean
far.
it's interesting here, but it uh, that that last example isn't quite useful, but it does illustrate the point that you can just override the function definition and just here we're treating it as like the not operator. So uh, yeah, it's not true, and then you get that sentence. Um, the I think the next set of examples are going to be a little bit more interesting.
Yeah, yeah. So the next paragraph talks about the not operator and the fact that while you can override this. I'm going to choose to call it the bang operator because it makes more sense to me that way. While you can override this operator, the bang operator, you may not be able to override the not operator that Nelson has talked about, which is kinda synonymous to the bang operator. And in addition to this, we have other operators that you can see according to that paragraph that have fixed behavior and that can't be overridden. So previously we've talked about the concept of an operator being either binary or unary. And this next code example is showing you how to define a binary plus operator and how to define um, I think a a unary subtraction operator. And what we are seeing here is that we create a new instance of the document class, and it's called favorite, of course, just like before. We pass in the title of the document, the name of the author, and the string chocolate is the best as the content. And then we want to we are calling the minus or the subtraction method and passing in favorite as an argument. No, sorry. We are we are calling two methods in this statement. Inside the brackets, we are calling the plus method or the addition method, and we are passing in our object, which is favorite, as the argument. And then the value of that operation is the argument of our method call, of our subtraction method call, if that makes sense. So what output are we going to, us to think about this in a procedural kind of way? We're going to first ask ourselves, what is the value of calling the plus method with favorite argument? And when we go to the plus method definition in the document class, we are going to see that the output the output of this method call is going to be I am sure that, and then we fill in the content that was passed at the point of creating the document class we are dealing with. So the output of the expression in the brackets is going to be I am sure that chocolate is the best. Yeah. So that is the expression that is going to be returned by this operation in the brackets. But then remember, we are having a subtraction method call passing in another argument, and that is what is going to result into our final output of the unsure variable, whereby we're going to have I doubt that. Remember, in the subtraction method that is defined in the document class, we have I doubt that, and then you fill in the content. And in this case, our content is I'm sure that chocolate is the best. So you're going to combine those two statements and you're going to have a final output of I doubt that, I'm sure that chocolate is the best. Okay, this kind of statement doesn't make sense to me also, but I guess it illustrates what the author was talking about. But the English doesn't make sense. I don't know if it's clear to you.
I mean, the English here is sort of irrelevant. Like what you're doing is you're decorating the original content with
Yeah,
some other
yeah,
strings, right?
yeah,
The first one that you decorate it with is I'm sure that, and the second one you decorate it with is I doubt that. Um, but there's a subtle thing that's going on here that's interesting to me, and that's that these overriding these methods, you could choose to uh, to modify the content directly, but the author here has chosen to create a new document with with the new content. So it's not modifying the original object. It's creating a new object
yeah,
and it's modifying the new object um, with additions to the content string. And I think that's a really good way to go about it because it makes it so that um, if some other part of your code is depending on that original document, uh, you don't want it to change underneath you. So creating the new document object and working with that is is good for these plus and minus um, operations that do some possibly unexpected things.
yeah. I think like you said, it could have been also possible to change the initial object within the document class, and then you return the changed output. But then, like you said, yeah, it's better to have these operations happening whereby you retain the initial object you started with. So in this next section, just like before, we are saying that concept coming back of um, you're having basically anything that involves an operator um, involves a method call specific to that given operator. And I see that in this section you have the square brackets and the square brackets with the equals, and the book says, although technically these bracketed methods are not operators, the Ruby parser sprinkles some very operator-like syntactic sugar on them. When you say foo and then you have the 4 inside the square brackets, you are really calling the square brackets method on foo and passing in 4 as an argument, just like we've seen earlier. So I think if you're thinking about it in that way, you could also, for purposes of writing it more explicitly, you could say foo and then the period, and then you pass in 4 as the argument in the square bracket. And then similarly, when you call foo passing 4 as the argument equals 99, you're actually calling the bracket equals method on foo, passing in 4 and 99 as the arguments. Yeah. And this takes us to page 134, operating across classes. And I think I'm going to try to summarize this. The section starts with one thing about the unary operators or single object operators is that you only need to deal with one object and one class at a time. Coping with 2 objects doesn't present much of a challenge if you are dealing with 2 objects of the same class. But binary operators that work across classes can be one of those. Seems simple until you try it kind of jobs. So in this code, what are we trying to see? Remember before we overridden the plus operator to allow us to add 2 documents together. So you add a small document and another document, and then you get a bigger document. So what we are trying to see here is that, let's say we created a new instance of the document class, to which put in simple terms is that we created a new document. Is there a way we can use the plus operator, right, to add a string to the newly created document? Yeah. And in this section, it reads methods don't get much simpler than this. It just does a Ruby thing and assumes that the other operand is a document, or at least an object with a content method that returns some text, and lets it go at that. It would be nice, however, if we could add a string to a document, so that if we created a new instance of the document class named doc, we could get a new document by adding doc to a string. So basically, how do we go about that? When you're trying to do this and you've written the expression that is supposed to return the value of that addition operation in a certain way, you're going to have to keep in mind that the order that you've written that expression in is going to matter a lot. Because to have a method call, a plus method call return to you output, as you can see, when creating a new document, you're going to have a method, you're going to have other being called Now you're going to have other, the object other, which is passed in when you're performing the addition. You're going to have a content method being called on that object, which means that Ruby assumes that the object you're passing in that is involved in the addition you're performing should be able to return output when the content method is called on it. Otherwise, you're going to have an error. So what does this mean? This means that when you have a document and you're adding a string, the order matters a lot. And most times, when you try to reverse the order, and now, for example, in this case, you say out there plus doc, you're going to end up with a type error. And it's going to tell you that you can't convert document into string. And why is this? The author tells you that the trouble is that this expression calls the plus method on the string class, which blows up in our face because string doesn't know about the document class. And remember, the plus method is defined in the document class. So what this statement basically means is that the string class doesn't know about what it should do when a given string object receives a method call, when a given string object has the plus method called on it. So that any string object, given that the string class doesn't know how to handle this method call, any string object won't know how to handle this method, and thus you'll end up with this type error that you see above. And then they tell you that the bottom line is that if you want to define binary operators, in this case operators that are performing addition involving two objects, you need to either make sure that both classes understand their responsibilities. In this case, you make sure that a string object will understand what to do when the plus method is called on it. Or you should accept that your expressions will be sensitive to the order in which you write them. And this is what I talked about, that when you try to reverse the order, you're going to have the type error bar. So what are your options here? You either accept that, I have to write this expression this way for it to work, or you could make sure that the string object can understand what to do when the plus method is called on it. I think by overriding you can still, I think achieve that. So those are your two options, and that is what that section of the chapter tells you about. That if you have a binary operator and you're performing addition involving two objects that don't belong to the same class, you're going to have to find a way to make sure that both classes recognize a given method called on their respective instances and how to respond to that method. Otherwise, you're going to be restricted in the way you write the expression. And if you try to reverse that expression from the order you had initially used, you're going to have that error. And that takes us to the next section, which is staying out of trouble. And here you're asking yourself, when should you define operators for your classes and when should you just stick to ordinary methods? Put simply, we are asking ourselves when to override and when not to override. And the answer to this, according to the text, is that the easiest case, no, sorry, like most soft engineering questions, the answer to this one is a resounding, it depends. Mainly, it depends on the kind of object you are defining and the specific operations it supports. Now, let's say, for example, you're working with strings and you want to add two strings together. Given that Ruby ships with that functionality, and when you write that expression telling Ruby to add a string on the left to a string on the right, Ruby will be able to recognize that you're telling it to bring these two strings together. So the string object, or an object that is a string, just by the way Ruby is built, will recognize this operation. Just like other classes, for example, the matrix and the vector classes. And this takes back to arithmetic. I think you can just perform when you have a matrix, two matrices, and you're trying to add them. I think Ruby will recognize that, or it's given that it's possible in math, so Ruby will recognize that. As opposed to another class that you could be dealing with now, let's say a custom class, which doesn't recognize that functionality. So if you have two instances of that class and you're trying to add them, that class might throw an error because it doesn't recognize the inbuilt functionality of the plus operator. So in that case, you'll have to override the plus operator and tell it what to do. And for that, you'll define that specific method in that class and tell it that when you have two instances of my class and you're supposed to add them, this and this and this is what you should do. Yeah. Are we on the same level, Nelson? I don't know.
Yeah, I mean, I think so. Generally, what I try to do is um, I choose not to override methods that are already defined because it's confusing. You A lot of problems. By the way, the term for this is sometimes called patching because you're
Oh,
patching the you're patching these classes like string, to
okay.
be able to say string plus document, right? Um, and you would override the plus method to be able to get it to understand what it should do with documents. But there are implications that you need to think about, because if for some reason your performance, like you slow down the method, it's doing a lot more work, then if you're adding strings somewhere, it's possible that you could slow down the performance of your whole application because you're doing something funky in this plus method for string, or that you messed it up in some way, that you messed up the logic and there are corner cases, and all of a sudden you do have some failures on string that would never normally happen. um, what I try to do is, if I need to do something strange with string, um, I create a new method, a method that doesn't already exist, and I can use that method and uh, not break anything,
Overrated.
right? So um, yeah, I mean, generally people have people have reported problems with monkey patching, so I try to stay away from it as much as possible, and when I do touch it, um, it's for a good, valid reason, and the method that I use is to add new functions instead of overriding the existing functions. The only one that I use, um, the only time I really reach for overriding methods is when I'm implementing the comparable interface, and that's using the spaceship operator, which is the, lesser than, equal, greater than. Um, that series of three symbols together is called the spaceship operator, and it's used when comparing two objects to be able to sort them as greater than, equal to, or less than. Um, and and yeah, so for that's really one of the few times that I monkey patch stuff.
Okay. I think I'll have to read more about that. I've been hearing the term, but I hadn't really gotten to know what it means. So yeah.
Well, I mean, this whole chapter is basically that's what we've been doing. We're changing what the default method does. The plus operator is a method. we're
Yeah.
overriding the plus operator to do something new or different, and that whole process is called monkey patching.
Okay. So another issue that is highlighted still in this section of the chapter is that the way you perform, you write code performing certain operations should follow the convention of what people expect a given line of code to do. Let's say, for example, you have a plus b. People, when, like, now let's say when someone looks at that piece of code, they expect that you're adding a plus b and then you're getting a value, right? So if you've written that piece of code, you should at least make sure, for cases of the next programmer that will take on this code base, that they can understand what that code means and what it's actually doing. And you should help this programmer do away with guessing as to whether, if you add a plus b and you get c, then ideally b plus a should also c, because when you add 2 plus 3 you get 5, and when you add 3 plus 2 you still get 5. So if there's a distinction between how the addition of a plus b and b plus a is working in your code, then you should document that for the people, for the people that will take on the code base, and for purposes of understanding. Yeah. And I think that is what the author talks about next. Apart from this, they show you an example of that concept we talked about, whereby if you switch up the order, you're going to run into an error. And this is shown by, you create a new instance of a time class, time.now. I think the now method returns the current time, and then you store that value in the now variable. So you want to add 60 seconds to the current time, yeah, which is a minute. You create a new variable called 1 minute from now, and you equate it to now plus 60 seconds. Remember, now is the current time, so now plus 60 seconds will add a minute to the current time. And here 60 belongs to the fixed num class, and now the now variable belongs to the time class. Yeah. So when we say 1 minute from now and we switch up the order to start with a 60 plus the now, we're going to get an error. And the error is simply because fixed num doesn't know about time. So you can't write the expression the other way around. And this is something we talked about. Like, you run into this error if you're dealing with two classes that don't really know the extent of their capabilities and what given method, how their objects should handle given method calls. So that is something to keep in mind. And then here you have the percent string formatting operator. This is something we looked at, I think, in the strings chapter. Yeah. And they tell you that the formatting operator is great when you need to construct a string and you need more control than the usual Ruby string interpolation. And the code that follows, which reads that the value of n is percentage %d 42. What it basically means is that 42 is what should be in the place of the percentage %d when you're returning the output to the user. So that is also something to keep in mind. And the rest of the examples use the percentage operator to show you how you could play around with strings. Then another operator we need to look at in this this chapter is the equality operator, or variations of the equality operator, and how you can check whether an object on the left is equal to an object on the right, whether two objects are equal to each other, or whether, now let's say, two variables point to the same object, which means that they're equal, or if they're not. And this is something that is covered in chapter 12. Yeah, I don't know if also it's okay if you take us through this one.
Okay. Create classes that understand equality. An identifier. So we're in chapter 12, page 142. There's the first example there. So we have this document identifier class. And so um, we have this chapter. I'm going to try to summarize a little bit more this chapter. So we have this document identifier class that we create, and then we have some other things the going on here. Um, the I actually don't remember what the point of uh, that section was. Um, hold on.
No, I think you're talking about the document identifier class. I
Yeah,
think you're looking for you're looking in a specific folder. Because remember, I think when you're creating a document identifier, you specify the folder and the name. So you're looking in a given folder and you're checking whether a given document has a given name. I think that is what it's doing here. And when we see the codon, is it chapter 143? You pass in the folder when you're creating a new instance of a document identifier class. You pass in the folder, and then you pass in the name of the document. So here, he creates an object named first ID, and then another object named second ID, and he basically passes in the same things. The folder is secret/plans, and the name of the document is Reagan.txt. And then he says put they are equal if first ID is equal to second ID.
right.
I think that is what it does.
Yeah, so you're taking this document identifier class and you're trying to decide if two document identifiers are the same. And what are you the two
Yeah.
things you're going to use? You're going to use the name of the folder and the name of the file, and you're going to check if it's an instance of the same class. So your double equals there is going to check all those three things, that the class is equal, that the folder is equal, that the name is equal, and then um, I guess it doesn't care about the content, because the content is another place where you could this class could differ. Um, Actually, well, I mean, this is, I guess not. This is document identifier, not the document class. So the document
Yeah.
class actually has the content, and this is just the
Yeah.
document identifier. But theoretically, you could have other instance variables besides folder and name. You could have like created date or modified date, right? So
Yeah. Yeah.
so those things could differ, but if we don't care that those things differ, then we don't have to put those in the double equals. We only put the things that we care about to see if they're equal. Um, where this starts to fall down though is in the like uh, in the class. Like if there are other different types of document identifiers, if you have subclasses of document identifiers, then you would expect that subclasses of document identifiers would return equal uh, regardless. But because hard, uh, we're checking whether or not these return the same class, then what happens is that when you are checking a subclass of this, then equals this double equal sign returns false, which you have to be kind of careful. Um, the other thing, so on page 146, the other thing that you can do is check if the other class responds to this method. So if it responds to folder, if it responds to name, um, which means that it has a method called folder that you can call, or if it has a method
Yeah.
called name that you can call. And so then you're checking. Um, Now you've removed the check for the class, and you're just checking on the interface that it provides. The interface being these two methods, folder and name. And if that interface is the same, then okay, now we can check whether the folder or the name is the same. Um, yeah. So we're on page 146, the well-behaved equality. Unfortunately, we still have some
Yeah.
problems, both kind of a question mark as well as respond to question mark based implementations of double equals suffer from different classes may have different points of view problem that we came across in the last chapter. Um, so I forget how this fails. I forget how this example fails.
Oh, there's code on 147. I think it states that the trouble starts when we try to reverse the order of the expression. I don't know if that's what you're referring to, whether the reverse is true or not. Is that you're referring to about how the exam failed?
Yeah. Sorry, I wasn't follow. Yeah, I can't remember right now. Um, so we have we have this document and identifier that is the original class, and then we have this contract identifier that is a subclass. And I guess they were both implementing the double equals method differently, so that the order of the double equals mattered. Um, so that um if you do doc underscore ID first, it works as intended. And if you do con underscore ID first, it doesn't work because the contract identifier is the subclass, and that's the trouble that we're running into. Um, but I don't know.
Does it actually include the code of the contract identifier class? I'm trying to find it, but I can't see it.
Yeah, I don't see the code for that.
I think it just mentions that it's just a subclass. I don't remember seeing it when I was going through the chapter.
Right. Um, so yeah, that's one of the problems. If the double equals is implemented differently, then the uh, commutative property of the equals is not held. Which means that the order does matter, and A equals B will return something different than B equals A. But we also have the transitive property of this equals. So what's supposed to happen is if A equals B and B equals C, then A is supposed to equal C. But the way
Yeah.
that these classes have been written, that does isn't happening. Um, so our document identifier now it, like has to know about all the different subclasses. So in the on page 148, we're looking at the definition of the double equals method, and first we're checking if it's an instance of versioned identifier, and then we're checking if it's an instance of document identifier, and we do different things depending on what kind of class it is. um, it um, I don't like that at all. It means that anytime you add a new kind of identifier, you have to go in and remember to change the equals operator, which may or may not happen.
Mm.
There's no
Yeah,
guarantee
I think
that it's going to happen.
so. Like you said, what's happening here is that you wrote code, or at least in the book they wrote code that's already in the double equals operator, and that code is that operator is implemented differently in different classes.
Yeah, depending
I
on
don't
the
know if that's
class.
what you're trying to say. Depending on the class. So
So yeah,
when you
on
try,
page 148,
mm,
you can see the
mm,
code. So it says if other instance of versioned identifier, and then it says else if other instance of document identifier. So we're checking we're checking this, what class it is, and we know of two classes that we're interested in. One is version identifier and the other one is document identifier. And the code is different. We're doing a different thing based on what class we find.
yeah, yeah.
And so in theory, if we add another kind of document identifier, it's also going to have to this method is also going to have to change.
Oh yeah, now if you added the a situation whereby you also check for the created that, like you talked about before, I think that will also cause it to change again.
Yeah. So like a
Yeah.
dated identifier.
Mm.
Dated identifier is always going to return false, because if we don't change this equals method, then it's not an instance of version identifier. It's not an instance of document identifier. So it's going to just return false. We have to go in and manually check to see if it's a kind of document identifier.
Okay. Recording is on.
Yeah.
Yeah, so I think like Nelson has said, the bottom line is you might have a method of the same name, but it's implemented differently depending on the class. So when you try to call that method or to equate two things that belong to different classes, I think they won't be able to tell how to handle the method. So you'll have, I think you'll have the double equals operator telling you that the output is false. Is that the case? Because they won't be equal.
Right. So on page 149, it states the problem succinctly. in our efforts to do something sensible, we have managed to create a situation where A equals B, B equals C, but A does not equal C. And it says there's a couple things that we can do to work around this, and one is to add a method called as document identifier, so that we use so when we have our versioned identifier, we convert it to a document identifier, and then you can start uh, comparing it because they're the same type of thing. Um, so yeah, there's two problems. One was that uh, it it violated the transitive property of mathematics, and also whenever you um, added new subclasses, you would have to update this method, which is hard to remember to do, especially like if you change it a year down the line, you add a new class and you expect everything to work. Well, guess what? You forgot to update this method, so now it doesn't work properly. Um, okay, so it says, okay, now we're going to take on the triple equals operator, and uh, the triple so the triple equals for me is checking to see like if I remember correctly, the triple equals checks to see if we have the same object. Um, so it's the object identity, and I think um, well, I'm not sure, but I think by default it checks to see um, if the object ID is the same, which is the location in memory by default. But I'm not 100% sure on that. Um, but so here it's basically giving examples of pattern matching on page 150. So we start the pattern with a forward slash. We say Roswell and then any number of characters after that, and we close off the pattern matching, and we have the equals tilde to designate a pattern match. So the first the first example matches because we're using pattern matching. The second example, we're using the equal sign, the double equal sign,
Yeah.
and
Yeah.
it's not a match. Um, well, because one is a string and one is a regular expression, it's just
Yeah.
not
Yeah.
not going to work. Um, so the regular expression class has a triple equals method that does pattern matching when confronted with a string, and I did not know that. Um, that's new to me.
I think me what I recognized was the pattern matching operator and the fact that it has a squiggly line in front of like it's a single equals and a squiggly line. Yeah, I recognize that from the regex chapter, but this thingy, the the triple equals method, shipping with the regex p class, that's a new one. Yeah.
Yeah, and basically the advice is it's probably a good idea to leave triple equals alone. Um, yeah, I mean it's good. Like it's good advice to leave all of these alone. Generally, they're going to do some surprising things, and they're going to have some edge cases, like we've seen, where they break in surprising ways. Like that we saw the plus sign first. The first example was, well, it breaks the commutative property of mathematics. So uh, it matters. The order matters, right? A
Yeah.
equals B does not. mean that B will equal A. Like it broke that property, and then it broke the transitive property of mathematics. So A equals B, B equals C, A did not equal C. So it's just not something you expected to happen, but it's happening. Um, the hash tables and the equals method. Um, Geez, I do not remember this well enough to talk about it. Um,
Let me see. I think about the equal with the question mark method. I think I'll first go back to page 142. And what the chapter started with was that Ruby was that it told us that Ruby provides us with like multiple ways to check whether two things are equal.
mhm,
And here we've looked at the double equals operator. We've looked at the triple equals operator. In addition to those two, you have the equal question mark method as well as the EQL question mark method, which ship with Ruby. And what we have here is that Ruby. Now I'm quoting a sentence on page 143. Ruby uses the equal, in this case EQUAL question mark method, to test for object identity. In other words, the only way that this x equaling the equal method on x to check whether x is equal to y should ever return true if x and y are both references to identically same objects. If x and y are different objects, then the equal method should always return false, no matter how similar x and y might be. And I think a very good example of this is an example we saw in the topic about symbols, and which highlighted the fact that symbols are unique. So let's say you create a symbol, and the symbol is hey, and then you equate it to a value x, and then y is also equal to the same symbol. When you use the above code and you're like x, you call the equal method on x to check whether x is equal to y, you're going to have that expression returning true, because x and y are pointing to the same object in memory, which in this case is the symbol hey. Now, when you compare that to, now let's say you have x, which is a variable and its value is a string, and the string is hey, and then you have y, which is also a variable, and still it's the same value hey, which is a string. If you call the equal method on the variable x to check whether it's equal to y, you're going to have false as the output, because as much as both these strings x and y have the value hey, when you look at it like from the point of from the perspective of Ruby, these two variables are pointing to different objects in memory. So you can't say that x is equal to y simply because their value is the string hey. And I think that highlights the difference between strings and symbols when you're considering which to use in which case. So the bottom line is you're looking at ways of checking whether two things or two objects are equal in Ruby. Ruby gives you two methods, the EQL question mark method and the equal method. And the fact that it ends with a question mark, I think that tells you that it's returning either true or false. It's checking and it's going to give you a value of either true or false, depending on the two objects you're checking. You're checking whose equality you're checking. Sorry. So you have those two methods, and in addition to those, you have the double equals operator and the triple equals operator. And Yeah, I think that explains a bit about what I understood about the equal method that ships with Ruby.
Yeah, I mean, generally, uh, m- what I get from this is like, don't touch equals. Don't touch it. Just avoid it.
Oh yeah, this I feel like such an error might very quickly as a beginner. Like every time you override things that are inbuilt into Ruby, yeah, the errors you get, I think tend to be very, very, very confusing in so yeah, like we've seen, those are the ways of trying to check I don't know if that makes sense, Nelson.
Yeah. The next section, like in
I
the
was just
while, um, so like page 155. So it's basically saying um, we have numbers in Ruby, and you can compare these numbers, and they are, you know, contrary to the previous advice here, we are comparing things of two different types. So you can compare an integer that is an instance of fixed num, or with an instance of float, and you are doing the equal sign between these two different classes. But under the hood, Ruby is converting the fixed num class to a float and then performing the equality. So it doesn't have to do the kinds of things that we saw in previous examples, where comparing two different classes of different types leads to these problems of the mathematical properties of the equals. Um, so yeah, that's what Ruby does under the hood. It first uh, changes the two different types into the same types, and then performs the equals operation. And then it goes into the spaceship operator. Um, like the This is on page 155. Um, the spaceship operator should evaluate to -1 if a is less than b, 0 if they are equal, and 1 if it's greater than b. And it's used. So when do you use this? When you implement the comparable interface. Um, I keep saying interface because I come from I know that from a Java background, but these are
behavior.
it's not called an interface. It's the module. It's the comparable module. And so what you have to do with the comparable module is first include the comparable module in your class, and then implement the spaceship operator method, where you return -1, 0, or 1. And when you do that, it allows you to sort things easily in a collection. If you throw in a bunch, like let's say you implement this comparable to the document class, um, sorry, the comparable method into the document class, you can then throw a bunch of them into an array and then just sort the array. And it'll know how to sort them because the document class has implemented the comparable method. And that's the end of the chapter.
Yeah, so what I've understood, yeah, you talked about this. You called it the spaceship operator, right?
Yeah.
Yeah. So you're having three kinds of output that you expect. You're expecting either -1 or 0 or 1, depending on whether A is less than B, if they're equal, or if A is greater than B. So you're kinda checking for three things at ones, right? According to what I understand.
There's three
I don't know if
possibilities.
that's the case. Yeah. And then you talked about this thing that at the start of the in the wild section, which kind of differs from what we've been looking at, the comparison between two different classes. And yeah, you rectified it. I think you said under the hood Ruby does some converting and then proceeds to do the comparison.
Yeah. Yeah, I
Yeah.
didn't know that. I didn't know that's what Ruby did under the hood, but that's interesting. We have passed the 1 hour mark. I think this should be the end of the
Yeah.
meeting.
Yeah. Yeah.
Okay, so I'm going to stop the recording.
Yeah.